This is a review of how to find time and air for a projectile that lands above the point from which it was launched. In this case, it's not so much that students find the wrong time because they're trying to avoid using the quadratic formula. By the time we get to this type of problem, students are okay finding the time in the air. The problem occurs when they don't make the velocity final in the y direction negative, and they end up finding the wrong velocity. As the projectile is launched and it travels this path, it travels through the speed that it strikes the plateau twice. So once it hits the plateau, you have your velocity final in the y. But over at the same height over here, you had that velocity in the y going up. So you pass through the speed twice. As a velocity, the first time you pass through 15 meters, the velocity in the y direction is positive. The second time you pass through 15 meters, the velocity in the y direction is negative. And students end up taking the positive value for the velocity in the y direction, and they find the time the first instance where you pass through 15 meters, not the second instance where you pass through 15 meters. So in this case, when we do this problem, our y is going to be a positive 15 meters. Whereas before, when you landed below where you were launched, your y ended up being a negative. So we're going to do this the same way we did before. We're going to find our velocity initial in the y, with velocity initial in the y equals velocity initial sine theta initial. So velocity initial in the y will be 30 meters per second times the sine of 40 degrees, which give you velocity initial in the y of 19.28 meters per second. Just like we did last time, we're now going to use velocity final in the y squared plus, equals velocity initial in the y squared plus 2ay. I need to solve for velocity final in the y. I take the square root of both sides. So I get velocity final in the y equals velocity initial in the y squared plus 2ay and all that squared. Now, the projectile is heading downward, so we need to remember to take the negative root of this, showing that the velocity is in the negative direction or pointing down. So velocity final in the y equals 19.28 meters per second, all that squared, plus 2 times negative 9.81 meters per second squared times a positive 15 meters. Take the square root of all of that. Make sure we take the negative root. So our velocity final in the y direction will be negative 8.8 meters per second. Now, just like we did last time, we're going to use velocity final in the y equals velocity initial in the y plus at. So from each side, I subtract velocity initial in the y. It goes to 0 on the right. It stays on the left. I'm going to divide each side by acceleration. So on the right-hand side, it goes to 1. It stays on the left. Now, when I put in my numbers, my velocity final in the y direction was negative. So it's a negative 8.8 meters per second minus my initial, 19.28 meters per second, over acceleration due to gravity, negative 9.81 meters per second squared. And that will give me 2.86 seconds for the time in the air. Now, if you make a mistake and you make that 8.8 meters per second positive, you're still going to get a negative on the top. You have a negative on the bottom. You still get positive time, so you won't be able to catch your mistake that way. But what you're finding is, if you do that, the time it takes to get to the first time that you pass through 15 meters. So be careful when you do your work. Watch your positives and negatives.